Hi everyone, this is the fourth in a series of 5 videos for Year 10 linear relationships. In this video we're going to look at the equation of a line. So let's have a look what we've learnt so far. We've learnt the midpoint, gradient and distance formulas, how to graph straight lines, the different forms of a line, and how to graph regions. Now remember in the last video we learnt that the equation of a straight line shows the relationship between the x and the y coordinates, and this line y equals 2x take away 1 shows an infinite number of ordered pairs that satisfy the equation. So we learnt in Year 9 how to find the equation of a line just using the formula y equals mx plus b. You might get a simple question like this: find the equation of the line with gradient -2 and y-intercept 0, 4, and all we've got to do is substitute in for m and b. We'll start with our equation, and the gradient is -2 and the y-intercept is 4. And so the equation of our line is y is equal to -2x plus 4. But they're probably not going to ask you that question, it's too easy. How about this one? Find the equation of a line with y-intercept 0, 2 passing through the point 1, -5. Now in this case we've got the y-intercept, so we can do that. We know that b is equal to 2, so y is equal to mx plus 2. This point here satisfies this line, so we can substitute this in and solve for m. Now remember, this is the x coordinate, so that's going to go in there, and this is the y coordinate, and that's going to go in where the y is. So -5 is equal to m multiplied by 1 plus 2. And so m is going to be equal to -5 take away 2, which is -7. And now we're ready to write our equation of a line. Y is equal to -7x plus 2. Now there is a formula that can make our life a little bit easier, and it's called the point gradient formula. And it will find the equation of any line given the gradient m and a point x1, y1 that the line passes through. So let's quickly look at the proof of this formula. Find the equation of the line with gradient m passing through the point x1, y1. We're going to use the same method that I just used with a numerical example before. So we're going to start off by substituting the point x1, y1 into the equation y equals mx plus b, like this. Now I'm going to make b the subject. Well, that's pretty easy. B is going to equal y1 take away mx1. And now I'm going to substitute that back into y equals mx plus b. So have a look at this. See, I've got y equals mx plus, and then instead of b, I've got y1 take away mx1, which is this. We're nearly there. I'm going to take this y1 over to be with this y. So y take away y1 is equal to mx take away mx1. And finally, just factorize. And there's our formula. Right, here's our first example. Find the equation of a line with gradient -3 passing through the point 2, -2. So remember, this is going to be x1, y1, and this is m. It's just a matter of substituting them into the correct positions. So we've got y take away -2 is equal to -3, and then in brackets x minus 2. Right, that becomes a plus, and let's expand this out. Be careful of that negative there. So I get y plus 2 is equal to -3x plus 6. Now I can either put it in y equals mx plus b form, or I can turn it around and put it in general form, because it's not asked us to do one or the other. It's easy just to take this 2 over and write it in y equals mx plus b form. So there's our answer. Y is equal to -3x plus 4. Here's our second example. Find the equation of the line passing through the point 3, -4 with gradient -1/2. This time they've told us to write our answer in general form. So let's start with the formula. This is x1 and this is y1 and this is m. Let's substitute it in. Make sure you get it in the right positions. All right, this is going to be y plus 4. Now, whenever I get a denominator like this, I like to get rid of it, particularly if we're being asked to go into general form, so that'll help us. So I'm going to bring this 2 over the other side as a multiplication. It gets rid of the fraction there. Let's expand this out and expand this out as well. So I've got 2y plus 8 is equal to -x plus 3. Now into general form, I really want the x to be positive, so I'm going to bring it over here. And I'm also going to bring the 3 over. And so our answer is x plus 2y plus 5 is equal to 0, and that's in general form. Now, if we've got 2 points, then we're going to need to find the gradient first in order to use the formula. Here's an example. Find the equation of a line that passes through the points 2, -3, and 4, 0. So let's start off by finding the gradient. So remember, our gradient formula is going to be the difference in the y's divided by the difference in the x's. So it's going to be 0 take away -3 divided by 4 take away 2. And when we tidy that up, we're going to get 3 on the numerator and 2 on the denominator. And so the gradient of this line is 3 over 2. Okay, here's our formula. Y take away y1 is equal to m outside of x take x1. Now, it doesn't matter which point we use to put in here because both of them lie on the line. Okay, so I'm just going to choose this one. You can equally choose that one, it's fine. So I'm going to go y take away -3 is equal to 3 over 2, and then x take away 2. So substituting that in, this is going to become y plus 3, and I'm going to move this 2 over like this. So I've got 2 outside of y plus 3 in brackets is equal to 3 outside of x minus 2. So let's expand both of those brackets out, and I'm going to put it into general form. Here x is positive, so everything's going to go on this side. So I'm going to get 3x take away 2y, take away 12 is equal to 0. Okay, one last example. Now sometimes you'll be asked to find the equation of a line that's given to you graphically, like this one here. Now, it'd be nice if we could see the y-intercept, and if I could see the y-intercept, I'd probably just use y equals mx plus b. But because we can't, I'm going to work out the gradient and then substitute it into the point gradient formula. 2 ways we could work out the gradient. We could use the gradient formula, or we can just draw up the right angle triangle and do rise over run, which is what I'm going to do. So rise is 1, 2, 3, 4, 5, and the run is 1. So our gradient is 5 over 1, which is 5. Be careful using rise over run, because if your line is going down from left to right, it's negative, and you've got to explicitly put the negative in. But we're okay here because this is a positive gradient. All right. Here's our formula. We need to choose one of these points as x1, y1. It doesn't matter which one because they both lie on the line. I'm going to choose this one. So y take away 1 is equal to 5, and then in brackets x take away -1. We need to expand this out, remembering that this is plus. So y take away 1 is equal to 5x plus 5, and then finally bring our -1 over. Y is equal to 5x plus 6. Okay, that's the end of this video. In our last video on this topic, we're going to look at all of these rules all together and solve some coordinate geometry problems.